Well, how about we try our hands solving rational inequalities? And our first step when we're thinking about rational inequalities, I probably need to think about what could x not equal. And if I look at this denominator, 4x minus 3, I don't like that color. 4x minus 3, I can't have it equal to 0. And if I add 3 to both sides, then divide by 4, I see that x cannot equal 3/4. So I'm going to go ahead and kind of sketch out a number line here, and I'm going to put, how do I want to do this? Yeah, I think I'll put 3/4 maybe right about here. Okay, well, now let's solve this as an equality, and let's find out where there may be some real zeros, the x-intercepts, and then test our intervals. All right, so on the left side of this inequality, I don't really have to do anything to get it to a common denominator, but on the right side I do. So let's see, I got x plus 6 over 4x minus 3. And I'm going to just set it as an equal times 1 times 4x minus 3 over 4x minus 3. All right, and then I can just focus really on the numerator. So I've got x plus 6 equals 4x minus 3. Well, let's subtract 4x from both sides and subtract 6 from both sides. And when I do, I got negative 3x equals negative 9. And then divide by negative 9, and x is 3. So let's put on our number line x is equal to 3. All right, now let's test some intervals into our original inequality. Well, to the left of 3/4, I could try 0, right? So let's see, if I put 0 in for x, that's going to give me 6 in the numerator. It's going to give me negative 3 in the denominator. And divide 6 by negative 3, and I'm going to ask myself the question, is negative 2 greater than or equal to 1? The answer to that is no, and so this interval will fail. All right, then I got an interval here, let's say between 3/4 and 3, and let's use 1. So let's see, 1 plus 6 is 7, and 4 times 1 is 4 minus 3, well, that's 1. So then the question is 7 greater than or equal to 0? And the answer to that is yes, and so that interval is going to pass. And then let's see, we've got another interval out here to the right of 3, and 3 is included because it is a greater than. 3/4 is not included because it can't equal 3/4. That'd give us 0 in the denominator. Well, let's test 4. How about that? So 4 plus 6 is 10. And then in the denominator, 4 times 4 is 16 minus 3, which is 13. And so then I'm saying, okay, is 10 over 13 greater than or equal to 1? And the answer to that is no. So what is my interval of my solution set? Well, it's a parentheses because it can't equal 3/4, comma 3 with a bracket around it because it can't equal 3. And so in that region between where x is equal to 3/4 but not x is greater than 3/4 but not equal to, up to where it's 3 and equal to, that is my solution set. Shall we do one more? Yes. All right, let's see. So here we got x squared minus x minus 11 over x minus 2 is less than or equal to 3. And again, first up, what can x not equal? Well, if I set the denominator equal to 0, or say not equal to 0, so x cannot equal 2. I don't know, maybe let's put 2 right there. Can't equal that. I'm going to put an open dot there. All right, now let's solve. Well, again, on the left side of this inequality, I don't really have to do anything. So we'd have x squared minus x minus 11 over x minus 2. But then over here on the right side, I want to multiply this by 3 times x squared minus x, excuse me, x minus 2, I don't know what I'm thinking, x minus 2 over x minus 2 to get me to a common denominator. So then we'd have x squared minus x minus 11 is equal to, let's distribute that 3 to the x minus 2, 3x minus 6. And let's see, let's subtract 3x from both sides and add 6 to both sides. So then we've got, so subtract 3x to both sides. What have we got? What have we got? What have we got? Got. We'll have negative 2x. No, I got x squared, excuse me. X squared. Negative 3x and negative x is negative 4x. And then negative 11 plus 6 is negative 5. That's equal to 0. And let's factor this thing. So I've got x in my parentheses. My constant is negative. So therefore I'm going to have a plus and a minus in my parentheses. And I need two numbers that are going to multiply to negative 5 and add to negative 4. And I think 5 and 1 is going to do the trick. Yeah, okay. Let's set each of those factors equal to 0 so we can plot something on our number line to test our intervals. So x equals negative 1. And so let's see, let's put negative 1 out here, and it would be a closed dot because it's less than or equal to. And then we got x minus 5 equals 0, or x could equal 5. Let's put 5 out here. All right, so I got 1, 2, 3. I got 4 intervals, actually. All right, so let's see. If I take something to the left, less than negative 1, well, let's do negative 2. That may not be too bad. So negative 2 squared is 4. Minus negative 2, that's going to be a plus 2. Minus 11. And we're looking at less than or equal to 3. Let's see, 4 and 2 is 6, minus 11, so negative 5, less than or equal to 3. Well, yeah, that's true. That's going to work. All right, what about between negative 1 and 2? Well, let's try 0. Wait a minute. Is that right? No, wait a minute. I didn't finish that, though, did I? Let's see, negative 5. What did I do? Negative 2. I guess I need to finish that. It's still going to work. Let's say I'd have negative 5 is less than or equal to 3, and now I've got to divide that by, we'll use negative 2. Negative 2 is 4, and so then it is 5 over 4, or 1 1/4 less than or equal to 3, and that's true. So that interval's true. All right, now I'm testing between negative 1 and 2, so I can use 0, and I'm going to end up with negative 11 over 2. Negative 11 over negative 2, which is going to then become positive. Is that less than or equal to 3? Let's see, 11 over 2 is 5.5. And 5.5 is not less than or equal to 3. So that fails. All right, let's see. Let's get another test interval in here between 2 and 5. Well, let's try 3. So 3 squared is 9 minus 3 minus 11 over 3 minus 2, which is going to be 1. We're testing to see if that's going to be less than or equal to 3. Negative 9, negative 3. Let's see, that's negative 3, negative 11 is negative 14, so it's negative 5 over 1 is negative 5 less than or equal to 3. It is, so that interval is going to work. And now let's pick something greater than 5. I don't want to get too heavy with it. Let's just do 6. So let's see, 6 squared is 36. Minus 6 minus 11 over 6 minus 2, which is 4. And is that less than or equal to 3? Let's see, 36 minus 6 is 30. Minus 11 is 19. 19 over 4, it's almost 5, isn't it? It's actually 4.75, and 4.75 is not less than or equal to 3, and so that interval is going to fail. So then what is my solution set? Well, I can see out here I'm going, this passes, so that's going to mean I've got negative infinity, using a parentheses, comma, negative 1 with a bracket in union with parentheses 2, because I can't equal 2, out to 5, but I can equal 5. And so Shazam, that is my solution set. And then just for good measure, let's do one more. I'll probably graph some of these on the calculator, because when you got binomials or trinomials or polynomials divided by polynomials, again, you got to be careful how you enter it. So here we got 1 over x is greater than 1 over x plus 5. And again, what can x not equal? Well, x cannot equal 0, because it would fail right here. And x cannot equal negative 5, because it would fail right there. So let's see, let's get us the number line started. I'm going to put negative 5 out here. I'm going to put 0 out here. All right, let's see how I'm going to solve this. Well, I'm going to have to do some getting the common denominator on both sides. So I've got x plus 5 over x plus 5 times 1 over x greater than, probably should just use equal, 1 over x plus 5 times x over x. All right, what do we end up with here? Well, let's see. I don't have to use these denominators because they're going to all be cool. And put this in parentheses, make sure. So over here I've got x plus 5 greater than x. And let's subtract x from both sides, set that equal to 0. And so, well, I got 5 is greater than 0. Well, that's a true statement. But that would mean that anything over 0 is going to work, right? No matter what I've got. So in other words, it's got infinite solutions past 0. Well, let's just test intervals just to make sure. Let's see, you want to go with negative 6. How about negative 6? If I substitute in negative 6 for x, I got negative 1/6. I'm asking, is it greater than 1 over, so negative 6 plus 5 is negative 1. So is negative 1/6 greater than negative 1? That's tricky if I don't think about that real clear. And you know what? It is. Let's see, let me think about dots too. Got an open dot here, and got an open dot here, just to remind me. All right, what about between negative 5 and 0? Well, let's do negative 1. So I got 1 over negative 1. That's negative 1, right? I'm asking myself, is this greater than 1 over 1? Negative 1 plus 5 is 4. So is negative 1 greater than 1/4? Positive 1/4. The answer to that, of course, is no. And let's see, let's go out here to the right beyond the 0. Well, let's just do 1. So is 1 over 1, which is 1, greater than 1 over 1 plus 5, 1/6. Well, 1 is greater than 1/6, so that passes. Now, let's write our interval notation then. So I would have from negative infinity, parentheses, to -5, bracket. No, I got to open up there, parentheses, in union with 0, parentheses, can't equal 0, out to infinity, parentheses, and Shazam, there is my solution set. Solving rational inequalities. You haven't lived till you've done that.